start this. 5.4, equilateral and isosceles triangles. Does anybody remember what equilateral triangles are? What are all the same? All the sides are the same, right? All three sides are congruent. What about isosceles triangles? Two sides are congruent, right? So just keep that in mind as we do this. You don't have to write this down, but I do want you to draw it. So draw this real quick and then we'll explain it. All right, this is the base angles and converse of base angles theorem. Basically what it says is if I have a triangle and I have two congruent sides, I'm also going to have two congruent angles. And they're going to be opposite of each other. So like for example, I have this side here. The angle is opposite, meaning that it's going to be across the triangle from it. So notice I have this side, AB. This tick mark tells me it's congruent. And then if I go opposite of it, if I was to draw a line, the opposite angle is going to be congruent as well. Now notice opposite angles and sides. You see how this side goes here to here? This angle will never touch the opposite. Okay? This angle touches this side and this side, but it will never touch this side. Okay? So like I said, this angle is touching these two sides, but it does not touch this side of the opposite side. Okay? So remember, the opposite ones are across the triangle and they never touch each other. So same here on this other one. We have an opposite side and opposite angle that are congruent with each other. And if I have two sides that are congruent, I'm also going to have two congruent angles. And vice versa. What does vice, anybody remember what vice versa means? It just means kind of like the other way around. So I said I have two congruent sides, I have two congruent angles. Vice versa would be I have two congruent angles, that means I'm going to have two congruent sides. All right? Because when they give you the problem on the worksheet, they're not going to give you the sides and the angles. They'll give you the sides, and you have to figure out the angles are, or the other way around. Questions? All right, make sure you write this down. All right, when I look at this, how many congruent angles do I have? Two. So if I have two congruent angles, class, how many congruent sides am I going to have? Two. All right. And they're going to be opposite. So I started one of my angles. Let's start at angle A. And let's draw an arrow to the opposite side. Notice this opposite side does not touch this angle. Okay? So this opposite side is going to be congruent. So what's the name of that side? BC. Okay. This opposite side here is congruent because it's opposite of this congruent angle. It's BC. Next, do the same thing with the other one. Go to the opposite side that does not touch this angle. And what's the name of that one? AC. There's your two congruent sides. Don't write this down, but like if they gave you, for example, a triangle that had two congruent sides, and they said if A, B, and C, and they said find two congruent angles, you would just go across. That would be a congruent angle. Go across. That would be a congruent angle. So it'd be angle A and angle C. Does that make sense? So you can go backwards and forwards, with it. The sides and the angles are just across from each other. All right, next. Don't worry about writing this down at all. But all that this theorem says is that if you have a triangle that's equilateral, which we said is all three sides are congruent, then it's also going to be equiangular. What does equiangular mean? All the angles are equal, right? Remember, equiangular. Equal. Angular is talking about the angles. So if it's equilateral, all three are the same. And it's also going to be equiangular, meaning all three angles are the same. Okay, those go together. Three congruent sides, three congruent angles. All right? So write this down. Find x and draw it. All right, class, what kind of triangle is this? Well, when we just look at it, before we think about anything, what is it? It is a triangle, but look at the sides. How many congruent sides do we have? 3. So it's what kind of triangle? Equal what? Well, first with the sides, it's equilateral. And then, so, because when we look at the sides, it's 3 congruent sides, so it's equilateral. But if it's equilateral, it's also going to be equiangular. All 3 interior angles are equal, so it's this one, and this one, so they add up to 180. So 180 divided by 3 tells me that each one is what? 60 degrees. Okay, so this angle R here is 60 degrees. Angle S is going to be 60, and angle T is 60 as well. But we don't care about those. We're just focusing on this one. So if angle R is 60 degrees and it's also 2x, I know that those are equal to each other. So I'm going to say 2x equals 60. Okay? Because angle R is 2x, but it's also 60. So I can say, well, 2x and 60 are going to equal each other. And then what do I do to solve for x? How do I get x by itself? Divide it by 2. And x equals 30. All right, last one here. The easiest way I find to draw these is just draw an x and then connect the sides. Make sure you draw it big enough that you can fit more numbers inside in each corner. Okay. All right, we're going to have to really use our brain for this one. All right, these are the ones that are kind of challenging. So when I look at this, it says measure of angle 2 equals x plus 48. So, and then it gives me the drawing. So what I have to do is I have to figure out what angle 2 equals, plug it into the equation, and then I can solve for x. All right. But I have to start with, when I look at this drawing, you have to start with the number you know. Which angle do we know right now, the actual angle degree? 70. So let's start there at the bottom. Don't even focus on the top triangle yet. Just look at the bottom one. When I look at that one, my first step, what kind of triangle is that? Isosceles. Has 2 congruent sides. How many congruent angles? 2. And remember, they're on opposites. So we draw lines across. And I'm going to put a curve there. Draw a line across, and I'll put a curve there. Because that's saying that these 2 angles are congruent as well. So if this bottom left one is 70, what's the bottom right going to be? 70 as well. Because they're congruent. Okay, questions with that? Next. Step 2. I need to figure out what this angle is here. If I know the 2 of them, how do I find the third interior angle?
Add those 2 and then subtract them.
Yeah, add the 2, the 70 and 70, and then subtract it from 180. 70 plus 70, 140, and then 180 minus 140 equals how much? Was that quick math? 40. Next step. These 2 angles are what kind of angles? When they form an X with each other, they are vertical angles. And vertical angles are what with each other? Are they congruent or are they equal 180? They're congruent. So if the bottom one's 40, this other one's got to be 40 as well. Okay, you see how we're just figuring out one angle at a time, working our way up all the way to angle 2. Now this 4th step is this top triangle has how many congruent sides? 2. Okay. I got one there and one there. So if it's got 2 congruent sides, how many congruent angles? 2. And remember, they're opposites, right? So I'm going to draw a line. And if it has 2 tick marks, put 2 curves. So 2 curves there. Go opposite. 2 curves there. So how much is angle 2 going to actually equal? 40. Because this congruent one is 40, and the 2 congruent ones are 40. All right. If they're congruent, it doesn't matter if it's like, say, if one of them was x, the other one would be x as well. If it was 5x, the other one would be 5x. Whatever the angle is that's congruent, the matching congruent one's going to be exact same. So we found that angle 2 is 40 degrees. So angle 2 is 40. Am I finished? Is that what I was looking for? No. I just found what angle 2 is, but now I got to find x. So my last step, step 5, is I'm going to plug in 40 degrees for angle 2, so that's 40 equals x plus 48. And we want to solve for x. So what do I do to solve for x here? Minus the 48, or subtract 48. 40 minus 48? What? Not 8. Negative 8 equals x. So x equals negative 8. And that's it.